If you know anything about the ways of science, like King Arthur or Sir Benevere or myself,
Who are you, who are so wise in the ways of science?
I am Arthur, King of the Britons.
My liege.
you will know three things. Number one,
Does a wood sink in water?
No,
No, it floats. It floats.
wood floats on water. Number two,
What also floats in water?
a duck.
ducks float on water.
Why do witches burn?
5 minutes later.
Because they're made of wood. Good.
Number three, witches are made of wood. So what else floats in water?
Bread.
Bread? Yeah.
Apples.
Apples? Yes.
Very small rocks.
Small rocks? Not really. Nope.
Lead.
Lead? Huh. Nope.
Churches.
Churches? Nuh-uh.
Mud.
Mum? Yeah.
Cherries.
Cherries? Yeah, just don't have any.
Cider.
Cider? If it's in a bottle.
A great gravy.
Grape gravy? I have no idea what that is. So now that we've gone through things that float and don't float, why do things float?
Because they're made of wood.
Well, no. You see, this is flawed logic. Let's start with something a little more simple. The floor. And gravity. Due to gravity, I am being pushed down into the ground. So why don't I fall through the ground, into the earth, and then burn in the center of the earth? Well, you see, the floor is actually also pushing up against me. If not, I would fall through the ground. As you can see with these two Play-Doh stumps that I have, if the floor were made out of Play-Doh, and I would step on it, I would sink right through. Water is the same way, but with a trick. Water can move out of the way. Any solid object, like us or this pen, can just poke through water, meaning that the water molecules move out of the way. This is where things get interesting. When water moves out of the way, it needs to go somewhere. Therefore, whenever we place an object into the water moves and the level of the water rises. As you can see, the water is just at this level right here. But when I put this glass dish inside, the level of the water actually rises. So how are these things connected? Water itself is floating on water. In order for the water at the top of the water to be stable there, it needs to be pushed up by the water under it. Therefore, when we're moving or separating the water apart in order to put an object in, the water around it is actually pushing up with the same force as the water that we displaced. This is called Archimedes' principle, where an object, say this cube, displaces an amount of water equal to the weight of the object. Like we demonstrated earlier, metal usually doesn't float. So if I asked you, does metal float? Your answer would probably be no. But it depends. It depends on the shape. So if I take this boat made out of aluminum foil, you can see that it floats, but it's also made of metal. So what's going on here? How can metal boats float? How can giant tankers float? Well, it all depends on the shape in this case. This boat is displacing enough water that it can support its weight due to its shape. We have stretched the metal out so that it does this. As comparison, if I take this piece of aluminum foil and I scrunch it up into a non-boat shape, well, it's probably gonna sink. Let's see. 1, 2. Oh, it sunk. Well, there's one concept I need to introduce here, and that's the concept of density. Density is the measure of the amount of mass or weight that a material has relative to its size. You see, a perfect example is this cube. This cube, as we saw, floats, right? That means that it doesn't have a lot of mass compared to its size. But if I fill this little cube with metal balls, these magnetic metal balls, and I close it up, it's still taking up the same amount of volume, this little cube. But if I put it in the water, it falls right down like a rock. So it's not just about things being heavy or being light, it's about relative density. Materials themselves have a specific density, but if we change the shape of the object, we can make even the heaviest objects float. Imagine a giant tanker, a giant ship, a giant cruise ship. Those things weigh a lot, but they're mostly hollow and they sink under the water and displace such large amounts of water that they can stay upright. We can demonstrate that here. This boat is barely touching the surface of the water, and I don't know how many quarters this is gonna be able to withhold, but we're gonna try. Okay, so let me see. Okay, there. It's barely touching the surface. I got 1 quarter.
2 quarters. 3 quarters. 4 quarters.
And you can see that the ship itself is starting to go under the water in order to compensate for this added weight.
5, 6, 7, 8, 9. I'll get 10, 11, 12, 13.
Oh, it's almost starting to go into the seam right there. Whatever that number was. And I don't have enough quarters. Well, magnetic balls will have to do. Well, this boat is more resilient than I expected. So we're just gonna have to pile things on. Oh, it's still floating. But you can see that a lot of the boat is now under the water in order to compensate for this. There we go. And you see, as soon as it gets filled up with water, the weight of the water is added to the boat and it sinks. To sum up, in order for an object to float, it must displace an amount of water equal to its weight before it dips under the water. And this doesn't only apply to water. Air is a fluid that moves all around us, and we are displacing that fluid. Therefore, we could, in theory, float if we occupy enough volume, just like balloons do. Balloons are filled with a substance called helium, which is extremely light. So per unit of volume, the helium would float, and the shell or the balloon just helps contain the balloon, making us float. The same thing happens with hot air balloons. The hot air inside the balloon is less dense than the surrounding air. So the surrounding air pushes the hot air balloon up. So to finish this video, I want to put your knowledge to the test with these 2 curious things. If there's enough interest, I'll answer these questions in another video. So don't forget to like, subscribe, and comment down below. First of all is this experiment between alcohol, oil, and water. So you might know that oil actually floats in water, but in alcohol, this is not the case. We can see if we drop this oil in there, the oil actually stays right down here at the bottom. Let me see if you can see that a little better. There you go, you can see all the oil is down here. What I do now is you can add a little bit of water, just a little bit by little bit. Whoops, maybe that was too much. No, I think that was just perfect. So you can start to see it just right there in the middle. There you go. So see the oil is floating right in the middle. Second one is this experiment where you place a tiny bit of paper on, and then you put a paper clip on top. You let the paper sink on its own.
What's paper towel? Same difference. Or you pull the paper down. You let it sink. There you go. Be very careful not to disturb the paper clip. There you go. Come on. Fall down. There we go.
See, and you can make a paperclip float. So in order to make things float, it's not always about shape and it's not always about density. So what's going on here, right? See, so what's going on? That's your question. If there's enough interest, I can make a video about this. And if you poke it, it falls. See? Thanks so much for watching, guys, and I'll see you in the next video.